This tutorial is for 3rd grade, Module 3, Lesson 1. In Module 3, we continue our study of multiplication and division, taking it up to some higher numbers. In this lesson, we're looking at both skip counting and arrays to find greater multiplication problems. The first problem asks us to complete the chart, knowing that each bag contains 7 apples. So the top of the chart tells me how many bags I have, and then in the bottom of the chart I need to put the total number of apples. If I have 2 bags, then I know that 2 times 7 would give me the number of apples, and that is 14. In the next section I have 21 apples, and that's related to the fact 3 times 7 is 21. To find out how many apples are in 4 bags, I would just need to add 7 to the 21 in the previous box. 21 plus 7 is 28. To find out how many apples in 5 bags, I would add another 7. 28 plus 7 is 35. Another group of 7 gives me 42, and that's how many apples are in 6 bags. So we can determine our answers to these multiplication problems by skip counting, although it is a little bit difficult for some students to skip count by 7. I can also use arrays and the commutative property of multiplication to solve greater problems. Here I have 2 arrays. The first array shows me that I have 4 rows and there are 6 diamonds in each row. That multiplication problem is 4 times 6. So a reminder that the first factor tells me the rows, and the second factor tells me how many in each row. 4 times 6 is 24. In this array, I now have 6 rows, and there's 4 diamonds in each row. So this multiplication problem is 6 times 4, which is 24. The point being that if the students know the answer to 4 times 6, then they also know the answer to 6 times 4. We call that the commutative property, that the factors can be reversed and you still get the same product. Here are some other strategies that we can use to multiply bigger numbers. The first one shows me that 2 7s is equal to blank 2s. Well, if I have 2 7s, I know that's the same as 7 2s, and they both equal 14. In this problem, it's showing us that 3 times 9 is the same thing as 30 minus 3. If I think about this, 3 times 10 is 30. Well, 3 times 9 would be 3 less than that, because you're taking one less group of 3. 3 times 9 is the same as 30 minus 3, or 27. Here's another example of the commutative property. 6 times 3 is the same as 3 times 6, and they both equal 18. Here are a couple more examples. I have 80 equals 8 times something. Well, students usually learn their 10s pretty quickly. 8 times 10 equals 80. The next problem, 8 times 4, is the same thing as 5 times 4 plus 3 times 4. We've broken that 8 into 5 and 3, and we take each of those times 4 and combine their answers to get the product of 8 times 4. 5 times 4 is 20. 3 times 4 is 12. 8 times 4 then is 32. 20 plus 12. Here I have 4 times something equals 6 times 4. Again, that's the commutative property. They both equal 24. And the last problem, blank 5s plus 1 5 is the same as 6 times 5. Well, 6 can be thought of as 5 and 1. That means 5 5s plus 1 5 is the same as 6 times 5. 5 5s is 25, plus 1 5 would be 30. 6 times 5 is 30. These are just some examples of some strategies that students can use when they start solving multiplication problems using bigger factors.